In this video, we'll do an example in which we have a limit that is secretly a derivative in disguise. Okay, so the example says the limit as h approaches 0 of the cube root of 8 plus h minus 2 represents f prime of a for some function f of x and x value a. We want to find that function f of x and find this number a. All right. So the first thing to think about is, well, we have these two definitions of a derivative, one involving the limit as h goes to 0, and one involving a limit as x approaches some number. And looking at this limit, I would say it looks more like the h approaches 0, 1. Okay, so this looks like, let's recall that definition, f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. The one thing that I'm going to slightly tweak about this is, in the problem it tells me I want the derivative at some specific x value a. So I'm going to replace all of these x's by a. So let's go ahead and write an a in for all of those x's. So now if we match up some of the corresponding parts, I see that in my limit, this first term kind of matches up with the f of a plus h. So let's write those down. The f of a plus h should be equal to that cube root of 8 plus h. Okay, so the a plus h, a is some number, a plus h needs to be plugged in to my function. And if I look at the right-hand side, what's getting plugged in to this this cube root function is this 8 plus h. So it seems like this should be the a plus h. Okay, and that's suggesting that the a is 8. The a is matching up with 8. And what this a plus h is getting plugged into is the cube root function. So cube root of x, that is my function. That is f of x. Okay, it turns out that will be the answer, but one thing I should check is, I should check if the other parts of the limits kind of match up. If f of a will match up with this 2. So I should check that, check if f of a equals 2. And if I do a quick check, if I plug the 8 into this function, I'll get the cube root of 8. And that does equal 2. So that checks out. And that means now I've matched every part of the general definition to the limit that I have, which means this is a derivative. It's a definition of derivative for the function cube root of x at the x value 8. So these derivative in disguise examples, they can be a bit challenging. So be prepared to spend some time really thinking through them. What made this example a little bit easier is that it gave me this limit and it told me it was a derivative, and I just had to figure out what the function was and what this x value a was. But on the homework, you'll see some problems where you'll be given a limit and it won't necessarily tell you that it's a derivative. You may have to recognize that it has one of the two forms of our definition of a derivative, and that takes a little bit more practice. So be on the lookout for that. In terms of our goals, this was our third goal, recognizing when limits have the form of the definition of a derivative.